Perfect. Okay. So am I coming out? Can people at the back hear me okay? Perfect, thank you. I kind of almost lost my voice last week, which is probably the worst thing that I think's ever happened to anybody. That's what I felt at the time because I like talking. And so I've been trying to protect my voice, which didn't help. Well, I went out on the boat last night, and it had a lot of fun, but I'm not drunk, I'm not hungover, don't worry. But it was that whole quite a noisy, echoey boat, and so I woke up this morning worrying that I've ruined my voice again. So I'm going to try and speak more softly than I normally do, but it sounds like it's projecting over there. If my voice does give out halfway through, we will continue the presentation through the medium of dance, which may not go down well, but it'd be fun for videoing. So thank you so much for coming along to see this talk about cloud-native stuff. And actually, thank you very much for being part of the NDC conference here in London. One of the things we do as part of the organising committee is we're very careful to take feedback around how the event is running and the sessions you like and the sessions you don't like. And so it's really important for, for all of our speakers and the organising committee as well to get your feedback. So please, if you do have an opportunity to, don't just vote on the outside. I mean, we definitely like it when you vote on the way out. But if you can also, if you've got any other notes or thoughts or feedback that you want to give us about the venue, the way the things are arranged, anything at all, please just do let us know because it really does help us run a better event. Hopefully going from strength to strength. Also, the food here's been really good, so I've been quite happy about that. I'm looking forward to lunch. Anyway, you're here to learn about cloud-native stuff, I hope. Otherwise, you are in the wrong room, but that's fine. Just a bit of background. So my name is Sam Newman. I tend to write about microservices type stuff. I now run my own company, which it should really be Sam Newman and Associate. Rather than associates plural, but we'll skip over that bit. And I do sort of training, consultancy, advisory work for sort of startups and tech companies and things like that, as well as sort of bumble my way through as a lifetime conscious incompetent when it comes to all things technology related, which is partly what inspired this talk, because I frequently find myself sort of befuddled and confused about the state of the world and what's going on. And increasingly, people were talking to me about saying, well, I've been told I've got to be cloud native. And I said, why do you need to be cloud native? And they'd say, because my boss says we've got to be cloud native, which is not new to me because I've spent many years with people saying my boss told me we've got to be microservices. And beyond what that meant, I wasn't, that's what I do. I help people do that. And so now I've got to be cloud native, and apparently cloud native is also the same thing as microservices. And so I got very, very confused for a while. And so I've kind of spent the last year or two trying to pull apart what this means, why it's important, what it might mean for all of us, and what technology around this space might be. And so you can kind of see this as a look both at the history of where cloud native has come from, the opportunities it gives, whether it's the right thing to you, and what it actually means to some extent. Because the term is sort of, it's like digital native almost in a way. It's like I'm being brought up in the body, in the warm embrace of the cloud, like I've been birthed out of the cloud, whereas I just thought the cloud was where I stored my documents. And this is, we've got to get through a lot of the marketing fluff and the fact that we are in IT very, very good at coming up with terms and then rapidly devaluing them. We've seen with Moore's law, it's been doubling the transistor density every 18 months. And that used to, increase our clock speeds, right? We double our clock speeds every 18 months. That's typically what happened to a certain point. Now I think transistor density is just helping us devalue IT terms more quickly than ever before because we can more quickly put out rubbish and marketing on the internet. We have mass confusion about what even the cloud means. But let's talk about history a minute. And when you start talking to people, especially developers, about the cloud and the cloud as a tool for building applications and for building and developing applications, a lot of people will point to sort of things like Amazon Web Services, right, as being the first platform out there that was really giving us as developers the ability to build applications that were on the cloud. The focus on creating a cloud-based offering, and they were far from the first person that allowed you to run services somewhere other than on your premise, but the focus on giving us the ability to write a line of code to do that work was really the moment that changed for most of us as developers in this environment. Before that, you would typically have graphical-based systems, maybe with human beings being involved. And so just the fact that your workloads were running on somebody else's machine, the only thing that you gained from that was that somebody else was managing the machine. There was no real moment of empowering control that like we do get now for Amazon, and we sort of take for granted. It's probably worth reflecting on the fact that Amazon Web Services isn't actually that old in the grand scheme of things. I mean, the very first cloud offering that AWS put out was actually SQS, was just their little queue service. It was back in 2006. I started using Amazon stuff around 2008, 2009. I sort of accidentally ended up helping create the first public training courses for Amazon Web Services. And back then, you only had about 40 different things you can do with it. Now when you go to the Amazon console, you have a little search box in your console, and you have to have like a regular expression matcher to even find the product you're trying to bloody use, and it's getting very confusing. But it did start very modestly back in 2006. In a way, though, this was always going to happen. The idea that we as organizations would be happy taking control away from ourselves, actually giving control to other people, because precedent had already been well and truly set. And really that started not with this stuff, but actually started even earlier, and started with software as a service. It started with people offering us capabilities inside our organizations, software to our organizations that was being run somewhere else. Rather than having to come and set it up inside your infrastructure, it was now viable things that are inside every sort of organization, whether they realized it or not. And when I was first having initial conversations with clients about whether or not they wanted to adopt Amazon Web Services, they said, oh, well, we can't have things running on other people's machines. That's scary, and that's bad things will happen. We can't do that. It's dangerous. And then you'd explore this a bit more with them and say, so you're running Salesforce? They go, yeah, of course we've got Salesforce. Everyone has Salesforce, right? Salesforce launched in 1999, believe it or not. It's now got a market cap somewhere north of $60 billion. A great success story, actually, for a Java monolithic-based system, by the way. And all these organizations that were quite happily already putting a significant amount of their data and processing out of their network perimeter into a centralized SaaS-based product. And once they realized that started saying, oh, we are actually already doing that. Okay, so maybe we can go a bit further. I think in terms of cloud-native applications and thinking more about an opinionated style of developing for the cloud, I think another watershed moment was probably Heroku. Amazon's approach early on with AWS was sort of trying to position themselves to an extent like a utility. Like, we provide electricity. You use it how you see fit. We're not going to be opinionated about how you use it. And if you were an early adopter of the AWS technologies, you'd realize that frequently you were just using their technology, but also managing to electrocute yourself frequently around that as well, because there weren't really strong opinions about how that stuff was used. It's just a tool, right? Heroku was very different as a platform. It's still, I think, the gold standard for a developer-focused platform as a service. It's no surprise that multiple organizations have basically come up with command lines, for example, that just copy what Heroku does and copy the Heroku life cycle. Some of you may have used Cloud Foundry inside your own organizations. That was completely retooled to copy the life cycle and command line and abstractions from Heroku, so back in 2007. Heroku had been trying to create a platform as a service that was developer-friendly and started trying to think, well, there's this interesting balance that comes here, right? To create a platform as a service, you have to create a level of abstraction. You have to hide away some detail from the developer. But what parts of those abstractions do you still make visible to people? And so they started thinking about the primitives that we cared about from a platform as a service point of view. Sort of out of this work came something called the 12 factors. I'm sure anyone here sort of heard of the 12 factors or 12 factor apps? Yeah. And this was sort of it actually remains one of the best examples of somebody trying to put together a playbook of how to build applications that work on the web, work on the cloud. The thing to understand about the 12 factors is they're actually quite nice and prescriptive. It's actually a combination both of a collection of constraints. By that I mean, you have to do these things, otherwise your application won't work well on the Heroku platform. But also there's a whole lot here which is just about good developer principles and good developer practice. So although the 12 factors are now used much more widely, its history and its background was very much a set of principles that ensure that you can work well with the Heroku platform. So there's some interesting stuff in here. Some of it is still quite detail-oriented, and I think doesn't necessarily stack up when we look at the more modern ways we now deploy applications. But there are still some really good pieces of advice in here. You know, we look at something like backing services. We'll start actually trying to push us away from this idea of thinking about, you know, trying to actually move our thinking to saying a database is just another service on a network. It's not something special. It's just another thing you talk to. Or looking at things like how we think about processes, scaling via separate, shared, nothing, stateless services. And, you know, great no bones about it. Part of doing that meant you got the most out of the Heroku platform. This was also partly about them steering their customers away from behaviors that would make it really hard to use their product. But also, it's just generally good advice. And so much of this sort of mindset comes into what we talk about now in terms of microservices. Microservices just being an opinionated form of service-oriented architecture. So the 12 factors are great and they're sort of useful, but when people say cloud native, I look at this and still think, well, it's not quite the right level of abstraction to explain what cloud native means or what a cloud native application even is. So I went digging around, and Google is always your friend, and you turn up all kinds of interesting opinions and views from different sort of agencies and analyst-type firms, one of which I turned up was from the Open Data Center Alliance, and they have a maturity model. Now, in general, I don't like maturity models because I feel that sometimes maturity models can always, so that they say that, you know, level 4 is better than level 3. It tends to imply a linear journey. And I lived through the Software Engineering Institute's capability maturity models in the 90s, and no, it didn't really help deliver better software. And so I'm naturally pessimistic about maturity models from that point of view, but nonetheless, diving into the detail can be interesting to talk about a journey you might go on. So let's take a look at what the Open Data Center Alliance talk about in terms of cloud native. They have all these nice levels, right? So we start at virtualized, which is you're just on virtualized infrastructure. So that means you're level 0 cloud native. I'm going to get a t-shirt with that. I am level 0 cloud native. And we go up, we've got loosely coupled, we've got abstracted, where services become stateless. Sort of interested that, you know, I'd argue it's quite hard to make services nicely loosely coupled if they're also stateful. So again, this is why maturity models can be quite confusing because it's sort of, it doesn't quite, that's not how things evolve. And to be level 3 adaptive, you're going to be an adaptive organization embracing the full power of cloud native. We hit one of the early things we do when we start exploring the cloud native space. And this is this idea that we should be cross-cloud and cross-vendor. So to be adaptive, an application can dynamically, this isn't a good word, migrate across infrastructure providers without interruption of service, which I don't know anybody that does this. Literally, I don't know anybody that dynamically manages an application, a non-trivial application, across multiple cloud vendors with 0 interruption of service. Does not exist. Doesn't. You'd think the big organizations, the big .coms, they might make heavy use of other cloud providers. They might have multiple cloud providers in their mix, but they're not dynamically managing workloads across different cloud providers. Guess who doesn't get to be adaptive in this model? Google and Netflix do not, according to this model, fall under level 3. So we should need to poke at this a little bit. There was this fixation, to an extent, on abstraction away from different underlying providers early on, which I don't think is always helpful. And this is the term that gets talked about, lock-in. You're worried about being locked into a provider. And this is one of the big scares and fears that put us away as CTOs and CIOs. They don't want to be locked into a provider. I don't want to be beholden to somebody for so long. A lot of organizations have been bitten from being locked into having to pay IBM or Microsoft big license checks at the end of each year because there's no other choice. And they think, well, actually, we've got portability now. Again, partly because of some of the lies we were told, or maybe not the lies, or the lies we told ourselves about the nature of cloud. Because we're worried about being locked in. We're worried about being stuck somewhere. And that's not great. It's embarrassing being stuck somewhere. And we shouldn't be stuck somewhere, should we? Because we were told that the cloud was utility, right? We were told the cloud was utility. Utility like the electricity that comes out of the socket or the water that flows out of your tap. So in the UK, we've deregulated a lot of that stuff. So I can go up to a web browser and say, I want to change my electricity provider. And it's all magic. It just happens. The nature of the electricity coming out of the wall doesn't change voltage, right? You know, the frequency isn't changing. I don't suddenly drop to 120 hertz and have to replace all my appliances. No, I flick a switch and it just works because the different providers are providing effectively an equivalent service just at a different price point and maybe from a different electricity source. The cloud isn't like that. These artifacts, these different product offerings are not replaceable in the same way, in the same shape or form. We don't have a U switch for cloud providers. You can't click a button and go, okay, right? And this leads, though, to some fuzzy thinking. Well, we can and we should, and because we can't, what we're going to do is we're going to have like another abstraction layer on top. And so we'll go out to a third party that will give us the ability to transparently move between vendors, and that stuff never works because you end up with the lowest common denominator problem, where you can only use the services that are common to all cloud providers, which means you get to take advantage of none of the underlying fundamental benefits of those platforms, but still pay the cost for the abstraction layer. So the first thing I'd say here, when you're thinking about cloud and the cloud strategy, is don't actually fixate on lock-in. Actually, I think a better thing to think about is migration cost. So you're picking a cloud service. First, understand that not all things that cloud provider offers are equally, complicated in terms of a migration away from some other service. If you think about the cost of migration, let's take a few core product type offerings that Azure, Google, and AWS all have, right? Now, if I've got something like blob storage, a binary large object storage, now those services across the different providers are pretty much equivalent. You might play around a little bit with the exact number of nines, durability and resiliency of those services. There's different price points, but primarily it stores binary data and I get binary data out. And actually the migration cost there is typically putting data on a drive and moving it, right? So it's actually quite an easy undertaking. The semantics, the difference in semantics between those services is pretty much equivalent. It's pretty much the same. Compute, it's a bit more work, right? Because although once you've got a running machine, it behaves, a running Windows instance on AWS behaves pretty much like a running Windows instance on Azure or some other cloud platform. Typically, the life cycle of management around that machine is different. You've got to spin it up. The APIs are subtly different and distinct, finding the right size machine for you. It's a bit more work, but once you're there, it's not so bad. Load balancers, well, these are different. Okay, so, I'm using an elastic load balancer, but I could actually replace an elastic load balancer on AWS with my own mod proxy little software load balancer, and I can kind of see how I could rework that into an Azure load balancer, and it's work, but it's manageable, right? And then we start looking at some of the higher abstracted services, like function as a service or backend as a service type offerings. These things that we typically talk about as being parts of a serverless product suite. Especially when you start looking at something like a back-end services, databases like Google Bigtable or AWS's DynamoDB, those type of NoSQL-oriented data stores have very different semantics. The way you store data across those different offerings is quite different. The way you retrieve data is quite different. The way those systems scale is quite different. Porting from an application that might be using Google's Bigtable over to Amazon to now make use of something like DynamoDB is probably going to require you to actually rewrite parts of your application stack. Therefore, a migration cost is going to be higher. And so if I'm working with a client and we're looking at a cloud vendor you're going to pick, and we're saying, well, how deep do I go into a platform? This is the kind of conversation you have. You say, look, these are all the things that could be really, really useful. These things, if you pick them and you realize you'd made a mistake with this cloud vendor, they're going to be quite easy for you to migrate. These things that you picked, these things are going to be more work if you need to move provider. Are you okay with that? And then what you need to do as well is think about how beneficial these things are going to be, right? So you can actually I've turned this into a quadrant. I do apologize. That's kind of what I do. As an independent consultant, we turn caffeine into quadrants. So now, you can start thinking for your given problem space, am I going to make use of backend as a service? Is that a really great benefit to me? Well, yes, then maybe I'm okay running the risk that later on I need to change my mind. And this comes then down to a pay now or pay later type decision-making process, right? If I really embrace what this cloud platform gives me, I get to take advantage today out of some really awesome stuff. And there's a risk that later on, I might have to move provider. And so do I take advantage of the cool stuff now and worry about that other risk later on? Or do I instead say, no, this is really, really awesome, but it's not a very portable thing. A great example would be Google's BigQuery or AWS's Redshift. Both fantastic systems, fantastic products for looking and querying large volumes of data, but the semantics don't really exist anywhere else. So yeah, I could get great benefit from using Redshift today, but actually, because I'm so worried about the cost of potentially moving that service, I might instead use a service that's not quite as good, but is maybe easier to migrate. Again, and the reality is, even for organizations that have made those choices, they tend not to switch later on because they build up a skill set on certain platforms. So even then, I'm a bit suspect. But it does come down to this sort of pay now or pay later. Another question you'll often get at this stage is talking about mixing different cloud vendors. So actually, this is a hedging a risk. So actually, well, if we're not sure, what if Amazon jack their prices up? This is always the concern. Once they get a significant share of the market, they'll start increasing their prices and will be locked in. Hasn't happened, and they do have a significant share of the market. It might still happen, right? So organizations say we should mix different cloud vendors. The challenge with this, of course, is that there's actually quite a deep body of knowledge you need to build up in terms of these sort of quite nuanced cloud platforms from Amazon, Google, and Microsoft. And accommodating in your organization a deep skill set around each of those platforms is an investment. It's an undertaking, you know. It's much more cost-effective for you to be really up to speed with one platform than trying to be up to speed with 3 platforms. Again, you might end up with a problem where you've got a bunch of people that have very broad knowledge but not very deep knowledge. Now, I think across an organization, this can still make a lot of sense. If you're across a big organization, you might actually want to have workloads running in, say, all the big 3 vendors, knowing that at an organizational level, at a global level, you're hedging your risk and you have expertise inside the organization for all those 3 vendors. I think it makes very little sense, though, within a single team, within a single solution space. You know, if you've got like 20 people, getting 20 people up to speed, or 2 or 3 or 4 different cloud vendors, is a lot of work and is a significant portion of your time, energy, and investment, quite aside from the fact that this would quite often result in some really nasty latencies when we start thinking about interconnected systems. And the reality is as well, when you really fully embrace a system and let yourself be, you know, locked in to an extent, that can sometimes be okay. So I'm an Apple user. I'm not an Apple fanboy, but I'm an Apple user. And some people, you know, a lot of people, especially who used Android and gravitated more towards the Android ecosystem early on, said the thing is, you're in a walled garden, Sam. You're in a walled garden. And there's this assumption that the walled garden is always a horrid place to be because you're trapped. You know, you can't get out. You know, you're stuck there forever. The thing is, though, like some walled gardens are really nice. Like you've got nice, relaxing, like deck chairs in front of a babbling brook. You know, someone comes over and brings you a nice dry martini, and you sip the martini, and there's lovely sun, dappled sun coming through the trees, and you can watch the cricket. And inexplicably, England are actually winning the Ashes this time. And it's a lovely place to be, right? It's fantastic. And no, you can't get out very easily, but why would you? Because it's awesome there. Some walled gardens are not like that, are they? Some walled gardens are full of, you know, knives and broken glass, and there's barbed wire on the walls, and there's prison wardens in there, and they beat you and take your money. But that is the thing. You know, some walled gardens are nice. You know, sometimes being stuck somewhere is a good thing, right? Sometimes it's like, actually, it's all right here. And this is the thing for us when we're thinking about adopting a cloud platform. You can really throw yourself into it and use all the really, really cool, awesome stuff that's in there. You can use those features which don't exist anywhere else and take advantage of them. And hopefully, those products have been created to work together, and so you can kind of get ecosystem effects. I think it's interesting to know that I don't actually think that happens as much with AWS. I think that's partly a function of how the Amazon product set gets created, right? You know, they have these autonomous teams that come up with product ideas, and they get things out to market. That's why they roll out features way faster than the other cloud vendors. But sometimes that means that they don't always communicate with themselves in terms of the product offerings, and so they don't often integrate with each other. So, you know, some of you may have seen at AWS reInvent, they announced a managed Kubernetes service, which was the least worst kept secret in cloud computing. Everyone knew it was going to happen, so they launched this managed Kubernetes service. They also released a service called Fargate that allowed you to run container workloads price per second. So they're only 6 months behind Microsoft on that one. But you can't use these 2 things together. And it's like they were launched by different bits of the organization, different product sets. It's like, well, how do we make these 2 things to work together? That's actually primarily why Lambda got launched. When Lambda was first launched on Amazon, the function as a service, it was primarily positioned as a way of gluing together Amazon's own services. They admitted this thing doesn't sometimes always talk to this thing, and so you often have to end up writing your own code to make these things connect, and so that's what Lambda was about initially, was about having event-driven JavaScript glue between a product set that doesn't work together. I think Microsoft does a better job. Different trade-offs as an organization, right? If you have a more connected product set, it's going to slow your time to market. A more autonomous team structure, you'll go faster, but you might not be as joined up. Okay, so don't worry about lock-in. Embrace the platform. We're going to come back to this idea of embracing the platform a bit later on. But we're here to talk about cloud native, so let's also take a look at another definition. So we didn't like the Open Data Center Alliance definition of cloud native, so there's got to be somebody else out there. Well, why don't we go take a look at the Cloud Native Computing Foundation, because they've got cloud native in their title, so they clearly know what they're talking about. They've got some really interesting definitions, which I think get much closer to what cloud native is and seem to be much more universally adopted as kind of the beats that we want to hit around these sorts of cloud native definitions. And so here's the big 3 points that they talk about from their definition, from their charter: container packaged, dynamically managed, and microservice oriented. Okay, so. Dynamically managed means flexible, right? It can scale up, it can scale down. Not necessarily inherently fault tolerant, but certainly something where you have a level of dynamism and the application itself is built with that level of dynamism in mind. Let's talk briefly about container package. Why is that even a thing, right? Why are we talking about containers? Partly because, they're so hot right now, but also partly because containers, when it comes to cloud platforms and cloud platform deployments, give us a whole lot of nice benefits, right? So isolated execution is a big one. When you run a program inside a container, you have an isolated set of resources and varying degrees of isolation from a security point of view that allow a workload to run in isolation. Now, if you're building an application that's going to work on the cloud, this is very useful because why? It allows for multi-tenancy. It allows you to have lots of different containers from different workloads running side by side on the same infrastructure, allowing for much better cost effectiveness, whether or not it's your cloud or somebody else's cloud. It's also great for us from a point of view of universal deployment. I deploy a container that happens to be running Java, another one that happens to be running .NET Core, another one that happens to be running Python. I don't care. I just launch the container. It either spins up or it doesn't. So uniform deployment, which again simplifies your deploy chain in terms of managing cloud applications. You don't care what's inside the box, you're just deploying the box. And also, actually, from a cloud native point of view, it's portable. There's a portability around containers. Because you have uniform deployment, because you're isolated execution, they are a unit, theoretically, of redeployability, not only across other machines, but potentially other providers. We'll talk about that a bit later on. So, so container packaged, but everyone now is talking about serverless. Actually, when people are talking about serverless, what they're actually talking about is FaaS. Most people make that mistake. They say serverless is just function as a service. The term serverless has been around for much longer than function as a service has. So function as a service, things like Azure Cloud Functions and Lambda, right? Little bits of code that spin up on demand, and when they're not needed, are not running. Really useful. There's varying qualities in terms of the tool chains around this. I think AWS Lambda's user experience is a train wreck, but it actually has got quite a rich service offering once you get beyond those problems. But these aren't container. Where's the containers here? Well, actually, these are using containers. They're just an implementation detail. One of the first little tricks I saw when Lambda first launched was someone worked out how to bust out of the Lambda sandboxes, and you can see the running Docker container those things are running on, right? So containers are still there. They're just being hidden away. This is the future for containers for most of us, by the way. Containers and unikernels as well are just going to become an implementation detail behind high-level abstractions. Okay, so we talked about why container package could be useful in a cloud environment where you want to spin things up and rescale and move things about. But what about microservices? Well, we have to address what I know is the biggest concern that all of you have right now, and that's the hyphen here, which has concerned me deeply. I mean, I wrote a whole book without hyphens, and yet the Cloud Native Computing Foundation is backtracking on that. But we still fight the good fight. Now, Pivotal is on my side. Pivotal's own sort of 4 pillars of cloud native are DevOps, continuous delivery, containers, and microservices, which is an interesting set of things to pull together. And I think they are reinforcing, but they also have this idea of microservices as being key to building a cloud-native application. Now, oddly, for somebody who is the person who talks about microservices more than most, I'm actually less on board with this being an essential part of a cloud-native application. And I think the reason I'm less on board is because there is this assumption that cloud-native is kind of a thing you either are or you aren't. It's like a switch. Click, I'm on. So that means I can't be cloud-native unless I'm using microservices. But if I've got an application that really embraces my platform, that can auto-scale, is resilient, where I've got like a nice abstracted dynamic management, and it happens to be a monolith, it's still a cloud-native application. Maybe I'm not taking as full advantage of the cloud as I could because it's not broken apart. It's still a cloud-native application. And so I also want you to think about that a little bit. It's not a switch. It's more like a dial. Right? You can be more and more aggressive in how you embrace the cloud platform. Right? Microservices allow you to more fully use the cloud platform underneath, but they're not necessarily essential. But nonetheless, they do have benefits in a sort of cloud environment. Right? Firstly, by breaking things apart, we allow our different parts of our system, their separate services, to be scaled independently. This can be really useful because it can, again, be about cost effectiveness. I can scale up just those parts of the system that require additional scale, that require improved performance. I can also scale those things down that don't need it, make more money, right? If I reduce my operational costs, I increase my profit margins. I also allow for independent deployability. Therefore, I can take advantage. It makes it much easier to make my systems robust and resilient in a cloud environment. Because again, with a cloud environment, you typically don't have an SLA for a given unit of compute. So Amazon have never had a service level agreement for the uptime of a single unit of compute ever. They actually only have an SLA for uptime of compute in a given availability zone. And that's only 97%, which is why you should have your solution scaled across a whole region inside AWS, which is more problematic if your system is more monolithic and can't be easily scaled around those environments. It also allows you, by breaking things apart, to use the right tool for the right job. For example, I can break apart my system, this service, I can look at its data storage requirements and realize, well, actually, this maps really well to Google Bigtable, so I'm going to make use of Google Bigtable here. You can actually pick the different cloud offerings where they give you these more powerful use cases, and they're offloading more of the administration work to the cloud provider. And it's much easier when you break a problem space apart to match those to the right cloud service for the job. This can actually allow you to take advantage of these benefits. So I'm not saying you have to do microservices for cloud native at all, but I think if you have an architecture which is broken apart into independently deployed processes, like a microservice architecture, it's going to give you more opportunity to really use the underlying platform and use what it's good for. Okay, so enough beating around the bush. Let's try and distill this down a little bit and talk a bit about what cloud native is based on my research, or at least what I think it is. And coming back to this idea of a journey that we're going on, let's talk about how we get applications onto the cloud and historically how we do it. And we start with something like a lift and shift. Now, I spent many years railing against the lift and shift. The lift and shift is where you scrape all the bits of your application out of your own infrastructure and you put it in like a bucket. And then you go over to the cloud provider and you sort of pour it into the cloud system. And it's not quite right, is it? There's things that don't quite work as well, and it probably costs you more. Most lifts and shifts end up with higher operating costs than leaving things where they are. But sometimes it's still beneficial. I mean, let's be really honest. Some people get a lot of value out of a cloud lift and shift. They're not taking advantage of the cloud at all, but often just being able to turn off or not, their data centers or not buy new hardware, that can sometimes be enough of an economic reason for a lift and shift. And so, yes, we should fight against it because you're not really getting the value out of it, but it works. So this is where you're on the cloud, but you're fighting it. It's like your application is there, it'd rather not be there, and you're doing all kinds of things that don't work very well on the cloud, but it's there, right? We then kind of start thinking about applications that are being built in a way where they can at least not fight the cloud anymore. So they're working with, not against, but not taking full advantage, right? This is sort of, and then we've got the cloud native stuff, which is applications that are built for the cloud and only a cloud provider, where the nature of the application means that you really do need a cloud platform for it to run. It could be yours. It's more likely going to be somebody else's cloud platform. So I think that when we think about traditional view of the 12-factor application, this is where they are. They're working with, not against, a platform. They're not necessarily fully embracing the platform. Cloud-native applications are going to be making use of things like serverless technology. I'm making use of these sort of much more dynamically, highly abstracted services. So as a definition, this is this idea of embracing the platform to be cloud-native, really living in the space you are in, is sort of key to this. So I sort of talk about a cloud-native application as being an application that's built to take full advantage of the underlying platform. You're optimizing for use with a specific platform in mind. And that's the key thing. You're designing it and building it and evolving it with a specific platform in mind. And you're being very wary about your abstractions. Let's come back to some other characteristics that I think come out of the cloud-native computing foundation. We'll talk in more detail about some of the characteristics of a cloud-native application. Okay, so built to scale. So you're building your application in order that it could be scaled more easily. Again, a microservice approach can help, but again, I think premature decomposition into microservices can be a very expensive undertaking. So again, as you're starting off, stick with the monolith at the beginning. Still buy my book, right? Definitely still buy my book. Like 5 or 6 copies is fine, right? One for each member of your family is all right. But start probably with a monolith, but be thinking about how could we scale the application and things like that. And again, fault tolerance. Fault tolerance is where you start looking maybe more towards a microservice architecture, because if you break apart your functionality into different services or different components, those components give you a degree of redundancy and resiliency, and you allow for partial failure, which is a very good way of maintaining resiliency of the system. So maybe decomposing into services to achieve those goals. We're pushing the work into the platform. And really, really key is this thing is fully automatable and automated. It was really interesting. I tweeted about how much of a train wreck the life cycle was of managing an AWS function. And then someone said, no, it's really, really easy. And then they sent me a tweet, which was about 20 tweets of screenshots of how you click the buttons on the GUI to make a Lambda function. And it's like, no, it's like one of those times where I didn't even have enough strength to explain why the premise of the answer was wrong. I just ignored it. But this is the thing, fully automated and automatable, right? Everything is scripted and reproducible as well. We should talk a little bit about platforms here. I said embracing the platform. Doesn't necessarily mean embracing a single provider. It means buying into a platform. And typically when we talk about a platform, what we're actually talking about really is buying into a certain abstraction, and probably an opinionated abstraction. And normally it's not your opinions, and that's the problem, right? So you're buying into somebody else's view of how we should build and manage our applications. And you hope it's an abstraction that sort of stacks up with how you think about the world. And we're actually getting better at this, by the way. I think I think function as a service is a really good, conceptually, even if the implementation isn't always great, I think conceptually is an excellent abstraction that is developer-friendly. So let's take a look at different layers of abstractions that we've seen in the cloud world. We started off here, right? We started off down at infrastructure as a service. This is really an ops level of abstraction. I have abstracted away the detail of how a machine gets somewhere, but you're provisioning, the big three. You're provisioning storage, compute, and networking. Abstractions at this level. It's a low-level abstraction. You can absolutely use this to build really effective cloud-based applications, but it's more work because you're having to deal effectively with the lower-level building blocks. Increasingly, over the last sort of 2 or 3 years, we started seeing the emergence of what we can kind of consider as container orchestration as a service. So platforms that allow you to deploy and manage containers over multiple machines. So someone gives me something like a Kubernetes cluster or Amazon ECS, and I can take my container and I say, I want 25 of these. Can you work out where they should go? So a high-level abstraction, I'm further away from the detail. I'm still talking in terms of scaling a container or a pod in Kubernetes land. And then, at the higher level above that, we've got platform as a service type abstractions. This is where your Herokus, you could argue, but sort of sit up here. You're thinking of cloud foundries and stuff like this. This is also very much where, some of the serverless offerings live, right? If we think about function as a service and back-end as a service, these are sort of primitive building blocks in the context of platform as a service, a higher level abstraction. And Kubernetes is sort of wandering around in the middle at the moment, probably working its way upstream as it absorbs more and more smarts and intelligence. If you're interested in Kubernetes, you should go and see Ben Hall's talk, which may have been yesterday. I don't know. No, it's today or tomorrow. Ben's doing a talk actually all about using Kubernetes on Windows. You should just go and check that out. Now, some people rail against abstractions. I'm sure some of you have read Joel Spolsky's post from many years ago called The Law of Leaky Abstractions. He signs off this whole blog post by saying, the abstractions are dragging us down. And what he's railing against here is the fact that some abstractions are leaky. Some abstractions say, yes, you don't have to worry about any of the detail underneath until you have to worry about all the detail underneath. And then what happens is people have to change the abstraction to open up the power to configure the things underneath because you need to get hold of them. And then suddenly you need to know not only the abstraction layer you're dealing with, but also the thing underneath. I spent about a year working with some technology called GWT, Google Web Toolkit, which was often called GWT, which the sort of running joke in the team I was working at the time was, I've got the GWITs, because it wasn't very nice. It was basically an attempt to abstract away the web and allow developers to create graphical interfaces using Java without even having to know anything about how the web works. Turns out, if you're delivering a web application, knowing a little bit about how the internet works might be useful. And so there are very few of those applications left. And if you use Google Wave, you've got a sense of the kind of user interfaces that GWT could deliver. The experience of creating those applications was not much fun at all. And not all abstractions are great, but I do actually think the function as a service is actually, I think, a really good abstraction. The key thing here is that those platforms don't give you a lot of power. And here's the other thing, right? Abstractions are often only leaky when we want to really configure them. I think the better abstractions are opinionated. There are things they don't let you do. They don't let you do certain things, and that is hidden from you. And that makes the abstractions nicer for you if they fit your mental model. But the more we want those abstractions to be able to give us the more power, the more we open them up, and the more they become problematic. And the reality is, look, as developers, this is what we do. Okay, Brian Merrick once said, developers turn caffeine into abstractions, which is, the other quote, we turn caffeine into code. But I think this is true. Like, we like creating abstractions. We like making things easier to use. The difference with a cloud-native application is you have to buy into a different person's opinion. It might match yours, it might not. But abstractions are valuable. They are useful. They are powerful. No one codes in machine code anymore here, do they? Probably. I suspect there's one or two of you might. Like maybe a couple of you use assembly. But no, because we know that, yes, while that gives us a lot of power, we're closer to the underlying hardware. We can theoretically use that to optimize for our specific use cases. In reality, most of us are a much higher level of abstraction because that's actually a much more productive place for us to be. And yes, it restricts us from being able to do certain things, but that's okay. That's the trade-off we make. We are also getting ourselves into a bit of a mess now, especially when we start running more complex systems and thinking about all of these different abstractions in terms of how our systems are built, right? I've got my underlying hardware, and on top of that, I've got my operating system, and yeah, okay, we're on board so far. And I'm going to put a hypervisor on that so I can virtualize my stuff. And so now I've got my virtual machines, and they're running their own operating systems. And now I'm going to run Docker inside my virtual machine layer as well, so I want containers. Why would I want virtual machines? And now I've got my container operating system on top of that. And now I've got my application sitting on top. And it's like this sort of being crushed by the weight of abstraction to a certain extent. And as I made the point recently, by the way, you're patching all this stuff, right? You're definitely patching all of this because I used to not talk about needing to patch my CPU. Turns out that is a thing we might want to be able to do in the future, right? So now I've got to patch everywhere as well. But again, we don't actually worry about that too much. And again, this is the whole thing. You're not just buying into somebody else's abstraction with a cloud-native application or a cloud-native strategy. You're also offloading work. You're letting somebody else deal with this. Typically, this is what we're doing. We're saying, look, I know conceptually this stuff exists. Like, I've built stacks like this inside organizations, right? They're paying to run. They can be very powerful for the people that live at the top of the platform. It's not much fun if you're down the bottom. But now we don't do it. We just say, this is yours. again, we're having to offload that work, but we have to trust the partners we work with as well. We're sort of in an interesting world. Coming back to the stuff that the Pivotal talked about, they said they see cloud native as also being partly about DevOps and partly about continuous delivery. We've already seen that containers and microservices might have a part to play. So in many ways, I sort of see the idea of a cloud native application as being the coming together of a whole lot of different ideas. We've actually lived in the last 20 years or so in IT. It's been quite an interesting time. We've had the emergence of agile development and lean development. I'm sure some of you here have read the Agile Manifesto, right? We sort of shifted how we think about building software. When I first was professionally writing code for money, we'd be talking about things like the rational unified process and different sort of forms of codified waterfall development. And you saw things like DSDM and thought, oh, there might be something better out there. And now we don't think about waterfall development. We think instead about smaller iterative-based development and embracing those ideas. Coming out of that mindset about increasing our feedback cycles was also the DevOps movement. DevOps being a cultural movement, not a technology movement, a cultural movement that said maybe we should talk to people that don't do the same job as us. Maybe rather than bring as a developer working for 6 months on my application and then sort of dropping it, presenting it to the ops team and saying, I made this for you. Like your cat when it brings in a dead rat or something as a present and just leaves it on your desk. We thought, well, actually, if we want to go faster, maybe we should be talking to each other and having this thing that some people here called empathy. Am I saying that? Empathy, right, for our common co-workers. Continuous delivery came directly out of Agile. It's actually, if you look on the Agile Manifesto, the 12 principles at the back, continuous delivery of functionality is there. Early on around Agile, of course, we weren't doing continuous delivery. How many people here are delivering software once a month or more quickly? How many people here are delivering once a week? How many people are doing more than one release a day? Right, okay. How many people here are delivering once a year? Only once a year, just the one person. So if I'd asked you the same question 10 years ago, that would have been completely inverted. When I first started, when I used to work at ThoughtWorks, I was there for quite a while. When I first joined at ThoughtWorks about 2004, the research I saw at that point said that the average sort of deployment time of the large corporates we were working with was they would deploy software and their systems would be every 18 months to 2 years. And the average tenure of their employees was less time than the average release cycle. That meant there had been some developers that had moved from company to company that never actually shipped any software. Now that's changed, right? That mindset's changed. All of us have applications on our phone that get released multiple times per day. The expectations of what we have as a customer has shifted because the things that we use in our day-to-day lives have changed. We get lots of features shipped to us quickly, right? Now we expect that of our corporate software. So this is why this shift, right? Continuous delivery was all about making that stuff a reality. And of course, these things reinforced each other. The DevOps movement and the continuous delivery movement work together. They're different things, but they're also overlapping in their mindset, and neither of them would have existed without Agile beforehand. If we look at what AWS was about, the Amazon Web Services stuff when it came out, that was a product, a commercial product, but that was inspired by their own internal requirements to enable continuous delivery and DevOps thinking. Amazon wanted to have small autonomous teams that were able to own and operate their software, to be able to ship software more quickly. They wanted high degrees of autonomy. They couldn't achieve that, though, when they were spending all of their time having to go and provision things manually themselves, raise tickets, rack up kit, connect cables. So they had to create tools internally to allow them to automatically provision the infrastructure they needed. This is what, when we start thinking about cloud and IaaS, it came out of these worlds, the desire to ship software more quickly and the idea that actually we can bring together development and operations roles. Microservices is an architecture that wouldn't exist without all of these things as well. Microservices is just a form of SOA, and SOA is just a type of distributed system. So from that point of view, the fundamentals haven't really changed that much. But the way in which we approach a microservice application delivery is very much informed by these ideas. Microservices are an opinionated form of software, of service-oriented architecture that optimizes for autonomy and optimizes for independent deployability of services. It's very hard to pull those things off without cloud, continuous delivery, and DevOps. You don't have to use cloud to do microservices, but it definitely helps. You absolutely need to think about the cultural side of DevOps and the sort of mechanisms and practice around continuous delivery to do microservices well. And so all these things, again, are coming together to give us the ability now to create our cloud-native applications. It's all these things, these ideas, these themes, these tools, these learnings from the last 20 years we've created better abstractions to allow us to do more and more things. And we're bringing all these tools and practices together. So it's been a kind of a fun 20 years. Roll forward, we've now got people like the Cloud Native Computing Foundation, which are trying to make these things easier for us to build. The inspiration partly behind the Cloud Native Computing Foundation, although they're sort of initially just seen as being the front for Kubernetes, in reality it's more complex than that. It's an attempt to say, look, this is the promised land, is that we should be able to offload a whole load of our concerns, buy into these other people's abstractions, focus on what makes us special, get software delivered more quickly, make our customers happy. But there's a recognition that there's still a process of putting together lots of bits to make your application work. And then that was quite painful, right? You're still pulling together lots of different abstractions that don't always work together. The Cloud Native Computing Foundation is attempting to actually bring together a whole lot of projects that work really well together. The idea being these things should fit together. There's a whole lot of projects underneath it. The goal isn't actually to have only one solution for every space. They have lots of different solutions that fit under their banner. So they actually effectively they're like a curation body, right? They help support these projects. They make sure they work together. They help put out training materials and things. So there's loads of really interesting projects up there. And coming back, but one of the things that is happening, and we talk about abstractions, we're worried about the lock-in and portability, but they're actually looking at those things as well, right? But coming back to the charter, there's some more stuff here. The Foundation's mission is to create and drive the adoption of a new computing paradigm that is optimized for modern distributed systems, system environments, capable of scaling to tens of thousands of self-healing multi-tenant nodes. And then alarm bells start ringing, because how many people here need tens of thousands of self-healing nodes? I didn't think so. Right? Most people don't, right? 10 is fine. So, now sometimes, right, you want to be able to scale to tens of thousands of nodes just because it's fun, or you see a conference track. Motorists don't have to worry about this stuff. But that's okay, right? Because these are platforms that will work and will scale down well. It's pretty worth noting, for example, that Kubernetes doesn't actually scale to tens of thousands of nodes. It's not capable of doing that at the moment. It might be in the future. Okay, we're talking about now standards emerging in this space, which is actually helping interoperability. This is also useful for us as people building applications, more abstractions that we can buy into. Now, in the past, I've been deeply skeptical about bodies coming up with standards. As I lived through the first wave of service-oriented architecture implementations in industry, where we had things like Oasis doing a lot of great work in terms of coming up with specifications, but we ended up with the WS Death Star set of standards. Like these huge heavyweight SOAP protocols that theoretically were going to make our lives easier and did nothing of the sort. At the moment, I'm cautiously optimistic. The standards that are coming out in the cloud-native space seem to be being driven by successful projects. A great example of that would be something like the Open Tracing API. People were using tools like Zipkin to understand the throughput of distributed systems. And out of that, and seeing how those projects work, they came up with Open Tracing API that's now making it easier to interoperate with other tools. Like vendors are now integrating with the Open Tracing API. There are even hardware vendors that are now supporting these API standards. So when you get, your Zipkin traces, you're going to start getting data points even from your own underlying network hardware, which is really kind of interesting stuff. This is the other part of the chart that's kind of interesting. Platform agnostic. The specifications developed will not be platform-specific such that they can be implemented on a variety of architectures and operating systems. Now, this was kind of a bit of a joke for a while. The reason was because for a very, very long time, everybody was in the Cloud Native Computing Foundation apart from one person, which was Amazon. And it was very much seen as this is all the other parties ganging up to try and fell the giant in the shape of Amazon. So we're going to talk about being platform agnostic because we want people to be platform agnostic because everybody's on Amazon. And although Microsoft is the clear number 2 in the cloud provider space, Amazon is out in front by a country mile at the moment. That has now changed. Amazon have actually come on board because they've realized if they can make it really easy for you to run solutions locally as well, they'll make more money. And one of the big drivers behind this idea of platform agnosticism is being Kubernetes. Kubernetes is a platform. If you build your application to work on a Kubernetes platform, it is portable across providers. So now we're starting to see those abstractions that might be closer to utility. All of the main cloud providers have a Kubernetes offering. You can get people that will run Kubernetes clusters for you on your own provider. You can run the own Kubernetes clusters inside your own organization. And you can build applications that are portable across those abstractions. That, again, that's kind of useful, right? Now, with my CTO hat on, I'm thinking, well, maybe I target that unit of abstraction. And yes, maybe I'm using Amazon's service today, but I feel that we could actually move it somewhere else. Again, sometimes the abstraction game is just about spending a bit more time and a bit more care and thinking about things and trying a few different things out, and every now and then we get it right. And Kubernetes might be the best we've done so far in terms of finding a developer-friendly abstraction for building more complex software. I think functions as a service is still a great abstraction for simpler types of workloads. So is it for you? Is it for me? Do I want to be cloud native? I think it's maybe, right? I think the first thing you've got to get your head around is you've kind of going to have to buy in to another vendor. You probably don't want to try and build your own platform internally to deliver cloud-native stuff unless you're an organization of sufficient size. There are some organizations for whom it's financially viable to run your own internal Cloud Foundry setup, for example, but those things can be quite expensive undertakings. If you're a smaller development team, you're going to have to buy into another platform. You're going to have to buy into a vendor. And you're probably going to have to accept that to really get the value out of this, I am actually going to have to buy into this vendor and be a little bit less worried about lock-in. If you want to know more about Cloud Native, there's a really great meetup that my friend Cheryl runs, and they always have loads of interesting people, vendors, people implementing Cloud Native technology. So if you're here in London, there's a Cloud Native meetup you can go along to. There's also the Cloud Native Computing Foundation are putting out loads of great stuff in this space. They're doing a lot of free training and certification if that's kind of your bag. So there's a lot more stuff out there for you to learn from. And finally, if you want to, you can buy my book. But thank you so much for your time. I think we're going to have about 5 minutes for questions. Okay, so anyone got any questions? It's either a good thing or a bad thing, I'm never sure. All right, well, thank you so much for your time, and I'll probably see you around the conference later on.